Airfield safety is critical during everyday operations in the aviation industry. While runway incursions continue to increase, the FAA and ICAO are devising ways to alleviate the issue, and airfield markings are on the list. New marking patterns have been conceived and implemented over the last 10 years to increase situational awareness by adding redundancy to the signage through pavement markings. However, new markings are only effective if they are applied properly. Markings installed poorly will perform poorly. Conversely, markings installed well will perform well and can make a difference by enhancing situational awareness on the airfield. Given the element of safety that high-quality markings provide, our objective is to define in more detail which procedures work the best, which materials are the most effective, and what is a good marking versus a poor one. Every airfield is unique, from its physical size to its climate. Many conditions affect the pavement markings. Evaluation of the airfield environment is the first step to identify the needs of the airport. Information must be gathered to ensure specifications are written to produce the best results. Pre-existing conditions of the markings reveal things to be considered before the painting process begins. Peeling paint is a common condition to be evaluated. While coating failures occur for many different reasons, they can create issues resulting in foreign object debris and premature pavement deterioration. The accuracy of existing markings must be accounted for as well. During the evaluation process, considerations of marking position, alignment, and accuracy must be made. Markings that are in the wrong place, incorrectly aligned, or out of tolerance will remain that way until specified to be remedied. The evaluation process mitigates many issues by addressing pre-existing conditions before they become complications. Many airports experience markings being obscured by heavy rubber deposits in the runway touchdown zones. But sometimes we find that markings can be marred by other contaminants, such as algae growth. Warm, humid environments are a breeding ground to microscopic algae, and runways are often home to these denizens. Some runway pavements contain elements in the aggregate that cause rust discoloration, thereby undermining a marking's effectiveness. On new pavements, steps must be taken to ensure a new marking project will be its best. Layout must be specified to ensure that placement and dimensions are accurate. If the surface is newly laid asphalt, a temporary coat may be called for to act as a primer. Or in the case of new concrete, curing compound must be removed to provide an adequate bonding surface for the coating. These factors, among others, must be accounted for in the evaluation process. Markings convey information to the end user. The overall effectiveness of that information is largely determined early on. Evaluation prior to writing specifications for application and maintenance is a crucial factor in the marking system and is a best practice. Surface preparation, by definition, is the removal of anything that would reduce the bond between a newly applied material and the surface. It's a known fact in the painting industry, 75% of all material failures are attributable to deficient surface preparation and/or application. Very few airports prepare the pavement surfaces prior to repainting. When repainting a house, the exterior is prepared first in order to establish good adhesion with the new paint. The same process is being performed here, creating a good environment for the new coating to adhere to the pavement. We are watching a water blasting operation clean a marking that will be receiving a fresh coat of paint. The water blasting equipment is followed by a vacuum sweeper, which collects the water and debris in its waste container. This is not considered paint removal. In this case, a relatively low pressure is applied to remove dirt, oil, and debris that would inhibit the new marking from bonding properly. When we look closer, we can also see that some of the existing paint is flaking up due to coating degradation from UV and weather. Rubber removal was found to be a necessary function in every busy airport in operation. Thick rubber deposits on runways can reduce friction and obscure markings in the touchdown zones. In this operation, the rubber is being removed in coordination with a repainting effort. The markings stand the best chance to adhere with the pavement free of heavy rubber buildup. Some airports experience so much traffic from large aircraft, they must repaint the centerline as much as twice a month. In this case, the rubber would not be removed prior to the painting operation. This may not be the best practice, but it is a practical solution as paint bonds to the existing rubber. Curing compound on newly laid concrete is known to have an adverse effect on markings. If not removed before markings are applied, as the membrane film sloughs off out of the new concrete, any coating applied on top of it will peel off at the same time. In this instance, layout has to be performed to designate which surface areas must be cleaned to accommodate the new marking scheme. Anything that might disturb the bond between paint and pavement should be prepared. Curing compound, rubber buildup, oils, jet blast residue, dirt and rocks, algae, and rust discoloration are all contaminants and should be removed to reduce the chance of marking failure. Many instances of surface preparation utilize a combination of equipment to provide the best bonding environment for paint. A vacuum sweeper used in conjunction with a water blaster is a common practice. Sometimes residual debris must be further treated with compressed air to remove anything else left behind in the recesses of the pavement. Surface preparation is paramount in the application and maintenance of markings, and has been identified as a best practice. Paint removal is vastly different from surface preparation, although similar equipment is often employed. Water blasting, sand blasting, shot blasting, and grinding are all viable options for removal. There are several factors to consider when discussing eradication, including the pavement type, age and condition of the pavements, as well as how thick the markings are. The highest degree of removal may not be needed on all markings. Generally, 95 to 100% removal of a marking should only be specified when a marking is obsolete and must be removed completely to reduce confusion. Simply blacking out obsolete markings is no longer acceptable. The degree of removal needed should be decided early on in the evaluation process and detailed in the project specifications. Many airports do not own equipment to remove airfield markings. A common practice is to hire a contractor to perform the work. It is extremely important to note that the correct and efficient operation of paint removal equipment depends on the skill and experience of the operator. Paint removal is certain to leave a mark on the surface, and some scarring should be expected as the coating is bonded to the microtexture of the pavement. However, a skilled operator can often keep the severity of the scarring to a minimum. Concrete joints and in-ground lights should be protected during removal by placing rebar or metal strips where necessary. Taking these kinds of precautions can save the contractor and airport time and money lost to repair. Vacuum sweepers are often employed in conjunction with removal equipment to pick up any debris left on the pavement. The brooms can be effective when cleaning grooved pavements, picking up smaller debris left in those grooves. Cleaning the area of any blasting media, wastewater, and debris is imperative, as new markings will often be applied in the same location. Layout is important for the proper placement of the markings and is a best practice. When done on new pavement or to straighten existing markings, pre-marking the pavement with chalk lines or paint spots gives the equipment operator guide marks to follow and also allows the inspector to check the layout prior to application for correct placement and dimension. When removing curing compound from new concrete, layout must be performed first as well in order to designate the areas that must be prepared for new paint. Enhanced taxiway centerlines are areas where intensive layout is required. Adequate time must be granted to lay out these marking patterns correctly to ensure the best product. Setting up for an operation can be different each time crews prepare to paint. The weather, materials, and equipment are all variables that can alter how smoothly the operation will progress. Here, materials are checked before they are loaded into equipment. Mixing and straining paint can reduce the chances of clogging the equipment, delaying the operation. Setup also includes the hardware itself. Operators must constantly make necessary adjustments to a truck's paint guns to achieve the desired spray pattern. Once the hardware setup is completed, test lines are usually applied and measured for correct width and minimal overlap. Here, a contractor has rolled out a piece of tar paper to test the width of a painted line. He then makes adjustments to the height of the paint gun to correct for any error. Nearly all operations require painting a few test lines before proceeding. However, most neglect to calculate coverage rates prior to application. These standard coverage rates are well documented in the specifications, yet in most cases, no quantitative measurements are performed to ensure how much material is being applied. A simple test used to calibrate paint guns is called a wet film thickness test. In it, a micrometer is used to measure the amount of paint being applied. The second part of the coating system involves the reflective media used in the marking. Here, we're watching a bead flow test being performed on the first of 6 bead guns. The test simply drops glass beads into a graduated pitcher for 10 seconds, yielding a volume that corresponds with a chart defining appropriate material usage dependent upon equipment speed. The test is repeated on each bead dispenser to achieve uniform coverage. The best quality markings result from closely monitoring these application rates. Calibrating equipment before each and every marking operation is a best practice. We found that the most common test during setup was an alignment check. No matter what kind of equipment was used, a pointer system was always in place. Mechanical pointers are common. However, laser pointers are starting to be used more often to guide the operator's eye. Although they can be expensive, they have great utility during nighttime operations when much of the painting occurs. Once equipment is properly set up, the painting operation can commence. In many cases, we found the paint trucks would travel at speeds up to and often exceeding 10 miles per hour. It was difficult for most operations to maintain accurate coverage rates traveling this fast. The reflective material did not anchor well in the coating at times, resulting in low reflectivity. This was sometimes due to a lack of material being applied, or in some cases, the beads would bounce or blow away traveling at high rates of speed. Empirical data indicated that trucks maintaining a lower rate of speed achieve higher reflectivity readings and generally better quality markings. In the aviation industry, time is not a luxury. However, markings did benefit when the painting operations slowed down. The best practice is to identify an optimum speed to maintain material coverage rates. During paint operations, crews utilize tools to help them achieve the best possible product. Cutoffs are commonly employed and create sharp edges as paint is applied over them. Metal plates and plastic lids are often used to cover in-ground light fixtures on center lines and hold bars. Prefabricated stencils are necessary for surface-painted signs. Windscreens are necessary on particularly breezy days and reduce the dispersion of materials. These tools, among others, aided in producing effective markings, and their use is recommended. Best practices are those where close attention is paid to details, where data is recorded and documented, and where quality materials are used in conjunction with capable equipment. The best truck-mounted equipment are those capable of painting a 36-inch wide line in one pass. Several paint guns must be installed to achieve an effective 36-inch marking. Wide markings are prevalent on airfields. Therefore, it is desirable to have suitable equipment for the job. Trucks that can paint two colors simultaneously are also preferable. On an enhanced taxiway centerline, this truck has the ability to paint the black, yellow, black pattern in one pass. Some trucks designed for use on the highways cannot attain the wider patterns. Therefore, multiple passes must be made, increasing the time to complete the project. Computerized counters on trucks prove to be a time saver as well. This skip mechanism is programmed to paint the enhanced taxiway centerline leading up to a hold bar, and saves a lot of time and layout. Trucks are generally used to paint long line markings, such as center lines and edge line. However, here a truck is being used to paint the designation numbers. This is a best practice, as truck-mounted equipment produces a more uniform marking. All markings should be applied with calibrated equipment as opposed to hand application to maintain higher quality. Much of the work performed by hand can be completed with greater success using small machines. Often, these are employed to accomplish the detailed work on the airfield. Ride-behind units are used in conjunction with small machines to improve their maneuverability and speed of application. However, caution must be exercised to maintain correct application rates. Bead dispensers should be mounted on the paint equipment directly behind the paint guns to ensure the beads have the best chance to embed properly in the coating. Many crews modify fertilizer spreaders and other mechanical devices that follow the paint machines. However, the use of pressurized beading systems synchronized with the paint gun operation produces the best results. Inspection of the markings once they are applied is typically the final phase of the operation. Quality control should be performed as the markings are being applied. Attention to detail and monitoring the equipment during marking installation can save the airport from having to repaint more often than is needed. In this instance, wind was preventing glass beads from adequately populating the marking. Quality control stopped the operation, inspected the marking, and resolved the issue. A makeshift screen was used to counteract the windy conditions and significantly improve the product. Inspections are often done during the day when it is convenient. However, it is imperative that markings are also inspected in the evenings for nighttime visibility. Many airports have inspection teams that drive the airfields during nighttime operations. Documenting markings with flash photography can provide a great deal of information about their conspicuity at night. Quantitative measurements of reflectivity can be recorded using the device seen here, called a retrometer. Gathering detailed information about markings in both daytime and nighttime conditions has been identified as a best practice. Evaluation, surface preparation, paint removal, layout, setup, calibration, and testing, equipment, and quality control and inspection. All of these comprise the marking system.